Here we're going to practice listing the outcomes in a couple different experiments. This is a really important skill that we have because in order to calculate probability, we need to know how many outcomes are included in the sample space. So for our first example, we want to flip 3 fair coins and list all of the different outcomes, the different ways that that experiment can unfold. For simplicity's sake, we're going to use H for heads and T for tails. Now, we are flipping 3 coins, which means we're going to have more than just heads or tails. And as these experiments become more and more complicated, it's going to be to our benefit to find a way to systematically list all of these so that we kind of have some sort of a pattern. This helps because we won't miss any outcomes. We'll make sure to include all of them. So to start off, usually when we write our sample space, we're going to write S for sample space equals, and then we'll use these curly braces. I always had a hard time writing them. If you just write a squiggly line, I'll know what you mean. But we want to talk about the different outcomes that this experiment can happen. So maybe we end up with 3 heads. So for example, that might look like heads, heads, heads. And that's the only way that I can end up with 3 heads. So okay, let's think about other scenarios. Maybe we have 2 heads. So you could end up with a scenario like heads, heads, tails. Maybe you get heads on the first 2 and then tails on the last one. Or perhaps you end up with something like tails on the first one and then heads on the last 2 coin flips. Or perhaps you get heads on the first flip, tails on the middle flip, and then heads on the last flip. And that's really all of the different ways that I can end up with 2 heads. Let's think about now the different ways that I can have 1 heads. Well, that would mean I have 1 heads or 2 tails. So perhaps I have tails, tails, heads, and I'm just going to reverse the ones that I see above. So instead of tails, I'll have heads, tails, tails, and then tails, heads, tails. Each one of these has exactly 1 heads. And there's 3 of them. That's the total number I have. So we've done, let's see, we've done 3 heads, we've done 2 heads, we've done 1 heads. The only other outcome that we haven't talked about is if we have 0 heads or no heads. And the only way that that can occur is if I have tails, tails, tails. And that should be all of our different outcomes here. So in total, if I counted these up, I have 1, 2, 3, 4, 5, 6, 7, 8 different outcomes to this experiment. So it helps sometimes to write out these different outcomes. Sometimes it's unfeasible to do this, but sometimes it helps to write out the different outcomes so that we can actually see what they look like. We can talk about different groupings of them, things like that. So next example that I want to take a look at is roll 2 fair 6-sided die and add the results. So this one's a little bit more complicated here. I might have something like a sample space. If I wanted to think about the sample space for 1 single die roll, well, that would look like 1, 2, 3, 4, 5, or 6. And there's a lot of different ways that I could go about this. If I wanted to list just kind of the total sample space for this, or if I wanted to think about just every single possible outcome for this experiment, because I have 2 different things I'm considering, right? I've got 2 fair 6-sided die and then adding the results. I'm going to have to be a little bit creative about how I list the different outcomes. So how about I list the first die roll? I'm going to create a little table right here. I'm going to create the first die roll. I'm going to list the outcomes going across the top. And we said that was either 1 or 2 or 3 or 4 or 5 or 6. And I'm going to make a little table just to, again, help me kind of organize my thoughts through this. And then for the second die roll, I'm going to list these over here. So again, it's still just a 6-sided die, so it's 1 or 2 or 3 or 4 or 5 or 6. And what this allows me to do is it allows me to keep track of these different outcomes and make sure that I don't miss any. So if I look at this section right here, this little cell in my table right here, well, that's the intersection of 1 and 1. 1 plus 1 is, last time I checked, 2. So here I'm looking at 1 plus 1 to get 2. Here, if I wanted to talk about this cell right here, well, that's 1 plus 2, that's going to give me 3. Moving over to the right one more, that's 1 plus 3, that's going to give me 4. And hopefully I should start to see a pattern unfold that'll kind of speed this process up a little bit. Next one, 1 plus 4, that gives me 5. 1 plus 5, that gives me 6. And 1 plus 6, that's going to give me 7. Okay, so my outcomes here are 2, 3, 4, 5, 6, 7. But that's only one row. I've got to consider the other rows as well. So moving down to the next row, 2 plus 1 gives me 3. 2 plus 2 gives me 4. 2 plus 3 gives me 5. And I should start to see a little bit of a pattern here. So 3, 4, 5. 2 plus 4 should give me 6. 2 plus 5, 7. And 2 plus 6, 8. Moving down to the next row, 3 plus 1 is 4. And if I look every single time I move to the right, I'm just adding 1. So 4, 5, 6, 7, 8, 9. Move down to the next row, 4 plus 1, 5, 6, 7, 8, 9, and 10. Down to the next row, 5 plus 1 would be 6, 7, 8, 9, 10, 11. 6 plus 1 would be 7, 8, 9, 10, 11, 12. And this is nice because it lists every single outcome for this particular experiment, which is actually a little bit different than just the sample space, which we'll talk about in just a second. So the outcomes that I want to list within my sample space are the results I get when I add these two die. So I'm going to go through and highlight these. Now, the thing about sample space, a sample space is a set. And when we talk about sets, we don't usually have any repeated numbers. If we have a number in the set, it's in it once. It doesn't matter whether that number's in the set once or twice or 3 or 4 or 5 or 6 times. Once it's in the set, that's it, we're done. So for my sample space right here, I'm going to say, all right, well, we've got 2, 3, 4, 5, 6, 7. So 2, 3, 4, 5, 6, 7 right here. Okay. And then if I move down to the next row, 3, 4, 5, 6, 7, well, those were already listed. I don't need to list them again. I'm just looking for any new numbers that I have, which in this case is 8. Next row down, 4, 5, 6, 7, 8. Again, we have all those numbers. 9 is the only new one. And again, we should start to see a pattern where only that last number gets added in. So we've got 9, and then we've got 10, we've got 11, and we've got 12. So this is what my sample space looks like. If I'm just thinking about the different results I can get when I add the two dies, I'm going to get 2 through 12, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. However, if I was going to talk about just the outcomes of the two die roll, in this case, you could count all of these up right here within this table, but we should have 6 outcomes right here by 6 outcomes right here. We actually have a total